Record. It's just me today. Yeah. So, we need to sit there and be able to look at graphs, and you guys can check out the TI-84s out of the media center as long as there's some left, which there probably is. But another tool we can use if you're just using on the Chromebooks is Desmos. I know they were looking at getting to where you actually can get the TI-84 app like on the Chromebooks. So remember the TI-84s, like the yellow ones that we had. So, and then those ones are a little bit more user friendly just because we're kind of used to using them. But until all that gets hammered out, Desmos works great. And you guys have seen Desmos before, right? So, and it's just desmos.com. So are you guys all there? Yeah. And then we're just going to go to the graphing calculator. So we're just going to click on that guy. And it's going to pull up with this cute little graph, right? So today we're actually talking on section 114. It's talking about finding intersection points. So if I graph two functions, the intersection point would be where the two graphs meet or where they cross each other, right? So in our book, they gave us some equations. So the first one they gave us was 2x squared. So if you do 2 and then x, do you know how to make it go squared?
No.
If you go shift 6, it's that little caret. If you push that, it'll get you to the square. But now you're up in the exponent, so then use your arrow key to come back down. Then minus 5x plus 6. So we should be able to get that in, and it looks something like that on your screen. You guys got that one? All right, so there's one function, but we actually need two functions if we're going to find where they intersect, right? So see the little plus? And then that f of x expression, and then that'll give you a line for a second function. And then we're going to put in negative 2x squared minus x plus 30. So it's kind of hard to see on our screen. Want me to give you a second to make sure we get that all in? You guys all good? And then over on the right, you have these pluses and minuses, which are your zoom in or zoom out. Or you can also, like on your touchpad, you know, click and drag, and you can move it all around too. Right? Yeah. You can actually, if you guys want, you can get a mouse, like the USB mouse. I don't know if I'm assuming the Bluetooth ones would work on these, but if not, you know, like just like the USB mouse. Pardon me?
I'm pretty sure AirPods.
Well, AirPods doesn't help us when it comes to like clicking. Yeah. But sometimes it's easier to use a mouse to move things around than it is those touch pads. So it's your guys' choice, right? So if we just kind of look at this little guy, right, and we're trying to figure out where it intersects, we're looking for those points. So we're like looking for this point, and we're looking for like this point, right? So the one nice thing about Desmos, if you click on it, it's going to tell you what the point is. So this one, where do they intersect? They intersect at the point 3,9. And on this one, if you go up there, it's going to tell you. I got negative 224. Yeah. Nope, you're fine. Nope, I know it's. I think I need a brighter screen. Yeah.
It looks like a 7 from here.
Yeah. Well, you have it on your computer, right? Because you're doing it along with me, and so you can see it. Right? Definitely, absolutely, right? So, but if you're using like a TI-84 calculator, those types of things, there's other little buttons that we can push. So one way we can find out where two graphs intersect is we can graph them, and then we can look at the graph and figure out where it is. Another way to find intersection points is to look at tables. So on our cute little Desmos, see these two little double arrows over here? Nope, sorry. It's the edit list. It's the little gear guess it's like a gear. If we click on the gear, see how you got a little table? All right, convert to a table. This would be to duplicate if you wanted 2 of them. If we convert that to a table, and then we do the same thing down here on this one, convert that to a table. When it comes to looking at our table, and then you can just click on it.
So I really should be using this to do all my things.
Well, how did that?
Well, how do you do that?
No, it's okay.
I can do all of them.
You're gonna click the little gear, right? And then it'll give you like a little table. But I thought there was a way to make my table go down farther.
Type in another number. See what happens.
Oh, there we go. All right. I guess you have to type in like the number. Ah, right. Right. And so if we actually, I'm just going to type it in. So if we're looking at those 2 tables and we want to find that intersection point, so like on the first graph, when we put in 0, our output was 6. If we look at the second graph, when we input 0, our output was 6. So we know those aren't the same points, right? So you're looking for where it matches up perfectly. Do you see any of that match up perfectly?
That's what I'm saying. Why does your graph look like that?
Oh, because it just, there.
It's still different.
Oh, you know what? What? No, it's just,
Wait, what happens if you put that magnifying glass down on the bottom left-hand corner? Yeah. Oh,
It doesn't, it still looks weird.
It kind of does.
your guys' doesn't look like that?
I mean, mine's kind of like that. It's
Or is this like, yeah.
Skinny. Oh, I changed my X.
So that's what happens.
See, that's what happens.
How do you do that?
I don't know.
Yeah, what'd you
Well,
do?
I'm so confused. I was like, I don't know how I did that.
Maybe we should restart.
Oh, wait a minute.
The back arrow question?
Controls.
Not that arrow, the other back arrow. At the top of the above your table. Top of the tables.
Wait a minute.
Calm down,
Yeah.
Lisa.
I know she said that arrow. Don't want to erase them all. Keep going.
Right, because now I still go, yeah.
Listen, calm down. There!
There we go.
No.
No, it's still, yeah. All right. We're okay. Somehow I changed my axes. I just got to find my little axes, where that's at. But anywho, but if you go through the table, and you can sit there and find where those points match up exactly. So for like on our first one, this 3, 9 is our, and we on the second one, we have a 3, 9. So those points are the exact same points. So we know that that's where they're going to intersect, right? Does that work? All right.
Still confused on how you messed up the arrow.
So now we're going to talk about when it comes to our quadratic equations, and we need to find out ways to solve our quadratic equations. So we know that we have a quadratic when it's in that form, like ax squared plus bx plus c equals 0. That square on our variable, so our highest degree is at 2, so that's squared. That's how we know we're looking at a quadratic. So there's a couple different ways that you can solve these. One of them is you can graph them, which we'll get to a little later. The other two are just going to kind of talk more algebraically when it comes to factoring and when it comes to the quadratic formula. So one way to solve them is by factoring. And then you're going to use that zero product property. Remember the zero product property? So let's say we had the equation x squared minus 3x minus 10 equals 0. Is that a quadratic?
No.
Yeah.
No, because it's a negative 3.
So what are we looking for if we want to find out if it's a quadratic? We're looking at that highest exponent, right? And that highest exponent for us is the 2. So that's going to tell us that it's a quadratic. If it was a 1, it would be linear, right? The highest exponent was a 1, it would be linear. And then 2s are quadratics. So I know you guys have touched on factoring these. Remember making like the X box or the area model? Do you guys remember doing that one? Where you guys like usually drew the little X. You did A times C and B, right? So technically, what's my A gonna be?
1.
A 1, yep, and C is gonna be
Negative 10.
-10, right? So you're gonna have -10 up here. What's B gonna be? -3, right? So we're looking for two numbers that when we multiply them, we're gonna get -10. So what kind of numbers do we have to have in order to get negatives?
One negative and one positive.
Yeah, so one's got to be negative and one's got to be positive. What can we multiply to get to 10? Yeah, 1 and 10 and 2s and 5s, right? 1 and 10 isn't going to help us to get to a 3, right, when we add them together. So we need 5 and 2, right? But when we add 5 and 2 together, we have to get -3. So which one's got to be negative?
Five.
Yeah, it's got to be the 5, and then this has got to be the 2, right? Yes.
So going back, the AC, we got -10, and then B is -3, obviously. But
Yes.
why is AC trying to get productive?
Because like technically there's a 1 right there, right? So our A is the one in front of the x squared, right? And then our C is our last one.
Okay, I just wasn't looking.
No, you're fine. Yep. So when you multiply them, you're going to get -10. See it now? Right. So then on this one, I know like when we were talking like last year, like you do the area model where you had to do the X and then the box. And you only had to do the box if the number out front was greater than 1, right? So technically we don't have to do the box, right? So we can actually write down what our two factors are. So it would be what, x minus 5 and x plus 2. And we can't leave out our equals 0, right? Because all we did is we just took this whole quadratic, this part of it, and we just rewrote it in a different form. We just rewrote it in this form. So we still have that equals 0 on there. You want to see another way of doing these? It's the exact same thing, except for doing the x part of it. Because it's a quadratic, I know that I'm going to have two factors, right? How am I going to get x squared? What do I have to multiply by to get x squared? X and an x, right? And then it's almost like doing the x without having to write the x. I know that I got to multiply to get -10. So we knew that one had to be positive and one had to be negative, right? To multiply to get -10, we know we're doing 5 and 2. And this is telling me it's got to be a negative. So it's got to be a +2 and a -5. Right. So on these simple quadratics, sometimes it's nice if you can get to where you don't have to always draw the x, to where you can kind of do it in your head a little bit. Right? All right, so we got to solve these still. So we got to get x's all alone, because we always want our x's to be alone. And we know that those two factors are technically being multiplied together, right? This is a factor and this is a factor, because factors are things that we multiply. And we got to get it to equal 0. So the 0 product property tells us that either, x plus 2 has got to equal 0, or x minus 5 has got to equal 0, right? How are we going to solve them for x? You guys good? What are we going to get over here? -2. Or x is going to equal +5. And a little clue too is because it's a quadratic and it's to the square, it's to the second power. How many answers do you think you might get? 2, right? All right. You ready for the second way? It'll be your favorite. Anybody know the second way we could solve a quadratic? Good job. Yep, the quadratic formula. So the quadratic formula is x equals, because that's what we want to do, right? If we're solving a quadratic, we want to get x all by itself. So it's how do we get x by itself? So the little formula is -b plus or minus the square root of b squared minus 4ac, and then, yep, all over 2a. So for poops and giggles, let's look at that same equation that we just did, right? X squared minus 3x minus 10 equals 0. And granted, we solved it by factoring, right? And the way I do these two, it's like my first thing is I always look at the equation, the quadratic, and I'm like, can I factor it? Because if I can factor it pretty quick, I think it's a little faster, it's a little bit more efficient than using the quadratic formula. But if I look at it and I'm struggling to try and figure out what those multiples are in order to do that, to factor it, it might not be factorable, or maybe I'm just not thinking clearly to where, because sometimes you look at it and like you're trying to get 15 and you can't figure out how to get 15, right? So sometimes then that's when I jump to using the quadratic formula. But the quadratic formula will work no matter what, right? So we know that our A is going to equal 1, right? What's our B equal? -3. And our C equals -10, right?
So it's just going from.
So yep, so we're just going to start plugging and chugging.
That's how you know what A, B, and C are.
Yes, yep. Because like the quadratic is ax squared plus bx plus c equals 0. That's just kind of like the little formula. Yep. So whatever is in front of the x squared is your a. Whatever in front of the x is your b. And then your constant term is c. Yep. All right. So you ready to start plugging and chugging? So -b, so that would be a -3, just to write it out long way for the first time. All right, plus or minus, whoops, the square root of b squared, so that would be -3 squared, minus 4 times, what's our a? 1 times our c, which is -10, all over 2 times 1, right? All right, ready to start simplifying this down? What are we going to have out front? That -3, that's just going to give us 3, yep. Plus or minus the square root of, what's -3 squared? 9. Positive or negative? Positive, right? And then -4 times 1 times -10 is going to give us? Positive 40, good job. All over 2? So, yeah. So, yep, so 3 plus or minus the square root of 49 all over 2, right? And you can start getting more efficient with these. Oops, let me get my other page up there. And then you can kind of get working a little, you can kind of skip a few steps. So x is going to equal 3 plus or minus, what's the square root of 49? 7. All over 2. So we need to simplify this down. So there's actually kind of like 2 problems, because if we look at the top, remember how it's plus or minus? So we're going to rewrite that as 2 different ones. So we're going to have 3 plus 7 over 2, or 3 minus 7 over 2. So x equals 10 over 2, negative 4 over 2, x equals 5, or x equals negative 2. How many answers did we end up with? 2. How many should we probably get? 2. Yep. Sometimes they repeat and they're the same number, but the 2. And is that the same answer that we got when we factored? It is, isn't it? So on this example, would you rather factor it or use the quadratic formula?
Quadratic formula.
Awesome, good job. Yeah. Like the one thing nice about the quadratic formula is no matter what, it will always give you an answer. Right? All right.